Okay, let me help. All right, guys. So what we're doing today, don't be a robot. The idea. What's the idea? No. Let's talk for real. Like for real. The whole idea today, guys, is this is what you're doing. When you have a curve, so let me go ahead and draw a curve. So let's say I have a curve. There's my curve or some function. And I find a tangent line at that curve. So let's say I found a tangent line right there at that point. And I want to, so there's my tangent line. If you zoom in enough, if you zoom in and zoom in and zoom in, and this is all I can zoom in on this, but assuming that you could zoom in on your tangent line, like really, really close, eventually that tangent line starts looking like that curve. If you zoom in enough, does that make sense? And you can use the tangent line to make a prediction of what that y value is in that curve as long as you're really close. That prediction will be really good. You can always use the tangent line to make a prediction, of course, but the further away you are from the tangent point, the worse the prediction is. So if you try to make a prediction, let's say this is my y scale. If you try to make a prediction of what the y value is at this x value, whatever x value that is, well, the real y value is that one. But if you use a tangent line to make a prediction, the predicted y value is that one. Does that make sense? So of course, the further away you are from the point of tangency, the worse the prediction is. And in Cal 2, you do the same thing, but with, you're going to make a function, you're going to make a prediction. We'll let the professor take care of that. Right now, we're just working with tangent lines. Very easy. If you guys have BC calculus, or if you guys want to come in next year when we're doing series, you can, you'll see. We'll apply this same concept, but to other, I'll stop talking because I don't want to lose you guys. Okay. Are we okay? All right. So that's all it is. So when you see this, like, oh, what is this linearization? If f is differentiable at x equals a, then the equation of the tangent line. Chop, why are they calling it something different? This is your tangent line, but they're just telling you that they're using it to make an approximation of what the real y value is. See, defines the linearization of f at a. The approximation f of x is very close, or approximately L of x is the standard linear approximation of f at a. The point at x equals a is the center of the approximation. Okay. Does that make sense? Maybe it doesn't make sense yet. Maybe you want to see a visual. Let's see a visual. So look at this. Find the linearization of f of x equals square root of x. All this means is find a tangent line. Find tangent. And then see, at x equals 4. Okay, so to find a tangent line, I need two things. What and what? Point and slope. I already have the point. The x value is 4. What's the square root of 4? There's my point. Now I need to find my slope. So here it is. F of x equals square root of x, which is the same thing as x to the 1/2. I haven't done anything crazy, guys. Next line, I write f prime of x. Are we still okay? What's the derivative of x to the half? Perfect. 1 over 2 square root of x. Are we still okay? Let's find the slope at 4. F prime of 4 equals 1 over 2 square root of 4. So 1 over square root of 4 is 2, and 2 times 2 is 4. Here's my tangent line. Tangent line that we will use to approximate square root of 4.02. Okay, remember that 4.02 is the next value. Y minus 2 equals 1/4 parenthesis x minus 4. Now I know you guys are visual learners, so you guys probably want to see this tangent line on that curve, and you probably want to see how good of an approximation that tangent line is to that curve at x equals 4, right? So I'm going to show you that. What's up? It's just the approximate y value of the curve is y squared of x. So if I want to find the y value at the square root of 4.02, I'm going to use this to approximate what that square root of 4.02 is. What is that value? It's a y value. Yeah, it's okay. I'll show you what I mean. I don't have internet. Hold on, let me get my hotspot out. I tried to use the school's internet, but every time I try to use it, it doesn't let me do stuff. What'd you say? Oh, I heard something. Oh. Okay, look at this, guys. You see that square root of x? Give me my tangent line. Or you know what? First, let me put the point 4 comma 2. So there's my point. No, I don't want to label it. All right, give me my tangent line. Y minus 2 equals, oh, my slope. Look what happens. Perfect. It does look like a tangent. Look what happens if I zoom in and I keep zooming in. And with Desmos, it lets us. Eventually, look how close. You see that line in green, which is my tangent line, and that curve in red? If I keep zooming in, doesn't that green start blending into that curve in red? So as long as I'm close to here, obviously at the point of tangency, it's perfect because the curve and the tangent line share that same point. But as soon as I move away from that point, it's no longer perfect. But if I use my tangent line right now, as long as I'm close, which I am because I zoomed in, as long as I close, do you agree that the green line will give you a really good estimation of the red? Yeah, it does. We have calculators now, so now it's not as useful as it used to be like in the 40s and 50s. This is how they used to approximate stuff. You can still approximate chocolate. Why are we learning it? We have calculators. Do you think we're going to have a calculator on the AP exam or a good part of it? And they're going to ask one question like this. And of course, there's more application than just this. It's just part. There's just, but there. Okay, I'll stop. Yeah. So we're approximating the y value. We're approximating what. Okay, so here it is. Ready? SQRT of 4.02. This is the real value of the square root of 4.02. See how we got 2.00499? Let's see how good of an approximate we got with the tangent line. So I take my tangent line. What do you think I'm going to put for x? Yeah, not 4, but what value do I want to approximate? Square root of 4.02. So I'm not going to put the square root in there because there's my tangent line. This is not my square root of function. There's my tangent line that I'm using. So I'm going to plug in x equals what value? 4.02. So here we go. I'm going to go, let's see, y at 4.02. This is my approximation. Approximate. And I guess I should have used L, but too bad. I already wrote y. So I'm going to leave it. 1. What? Because the square root gives me the perfect answer. I'm using my tangent line to approximate the square root of 4.02. I want to see how close it is. You know what I mean? 1/4, don't worry, 4.02. This, don't do my deltas before we do the lesson. Minus 4 plus 2. Check it out. So I have this, you can put an equal sign. 1/4 is 0.25. And then 4.02 minus 4, that's 0.02. Do you guys see that? So look at this. Equals. I can put an equal sign now because I'm just evaluating what this is. 0.25 times 0.02, that's let's see, 0.005 plus 2. So this is 2.005. From right here. I moved the point minus 2 to the right. No, ask, because I'm sure there was others that are like, I don't know what happened. All I did was I moved the 2 to the other side, and I just plugged in my x's. So what does that mean, Chop? What does this mean? Using approximation. This is approximately 2.005. What is approximately? The square root of 4.02 is approximately 2.005. How close was I to the real thing? Well, according to Desmos, I was pretty darn close. Look at that. Look how close we are. So if I come over here and I just scroll up, I hit this. So if I come over here and I just go, let me see, click, can I copy paste? Copy, paste, minus 2.005. Look how close you came. Look how close you came. You came 0.000006. I would say that is pretty darn accurate without a calculator. Wouldn't you? Isn't that cool? You don't find this cool? No, I think that's cool. Yeah, like see, so and all we did, what did we do? What's the concept? We found a tangent line of a point and then we got really, really close. What's hard about this? Nothing. The only thing that's hard is creating a model, but guess what? On the AP exam, do you think you're gonna have to create the model or do you think they'll probably give it to you? They will probably give it to you. So I just got the chills. We are doing the hardest problems possible. We're doing the hardest problems possible. The AP exam, don't worry, we'll have a sample question in here. The AP exam or any other exam, they'll probably give you the model. So this is about as hard as it gets. Now, if you go to MIT or if you go to a STEMI university, they're probably not going to give you the model. You have to create it. So when you go to your MIT school, don't be saying, "Oh, I didn't know, I didn't learn this." Yes, you did. Look, we're doing it right now. So okay, I'll stop. Sorry, I got too hyped there, guys. All right. Oh, I've had so much caffeine in me. All right, here we go. Look at this. I don't give you the model. It says use linearization, which is just a fancy word to say find a tangent line to approximate the square root of 123. Well, that's square root, so immediately I'm thinking, okay, well, my function is y equals square root of x. And I need to find a point of tangency. I need to get really close to the square root of 123. Give me a value, an x value, that's really close to 123, that is a perfect square root. 121. So here is my point. 121 comma, what's the square root of 121? That's my point. And now I'm going to find a tangent line. My tangent slope, sorry. So get my tangent line. Does everyone know what we're doing? Okay, I'll say it again. I'm finding a tangent line, and I'm going to use that tangent line to approximate what the square root of 123 is. All right, so here we go. Again, just like before, y equals square root of x. Well, I already wrote it here. My derivative is 1 over 2 square root of x. Chop, how'd you do it so fast? I already had it from over here. Are we still okay? All right. Y prime evaluated at 121 is 1 over 2 square root of 121. What's the square root of 121? So 1 over 2 times 11. So this is 1 over 22. Are we still okay? Nothing crazy, right? Tangent line. What tangent line? What's my tangent line that I'm going to use? Y minus 11 equals 1 over 22 parenthesis x minus 121. This is the tangent line that you're going to use to figure out what the square root of 123 is. Are we okay, guys? What's up, Morales? You okay?
Yeah.
Yeah?
Yeah, to the y value, why is the limit of the y value again?
That's my point of tangency. I plugged in. I wanted the perfect a location of where I have the perfect square root. I have y equals square root of x like this. 121 is way over here, and so here's the x value 121, and of course I'm exaggerating. That's the y value. So here's my tangent line like that, perfectly flat.
121 into the square root.
Square root of x, yeah, because I wanted a perfect value. I don't know what the square root of 123 is. Obviously, it's a little bigger than 11, but I know what the square root of 121 is. All right. What value am I going to plug in for x there? What value am I going to plug in there for x, Miss Kyle, that already finished a delta? 123, just like in the delta, right? So I'm going to write L of 123 is 1 over 22 times 123 minus 121 plus 11. And I should put approximate. You're right. Are we okay? Is anyone confused? Yeah, I didn't have to say L, guys. I could have left it as Y, but I decided to write L of X to try to be full. Yeah, take a calculator. All right. Yeah, that's fine. Here we go. Let's see what this is. You're welcome, Miss. 1 over 22 times 2 plus 11. So this turns into 1 over 11 plus 11. So 11 and 1 over 11, or 122 over 11. Let's see what this number is. Let's see how close we are. Should I do it on a decimal or should I do it on my calculator? What? Decimals? Okay. Let's see. So what do they want? The SQR2 123. So here's the real one. Let's see how good we got. 122 divided by 11. Look at that. Let's see how close that is. SQR2 of 123 minus 122 over 11. Look how close that is, guys. It is, if you take the absolute value of that, 0.000372. That's not even different by that much. Well, I don't know. I guess it's all relative. It depends on, but it's not a big number. So it's pretty close. Okay. I guess if we were working with microscopic numbers, then that gets it could be pretty far away. Like if okay. Like have you guys worked with atoms before? Like oh yeah, you have. You're like, in chemistry and all that good stuff. What's up, miss? I just did 11 times 11 plus 1 from like, I don't know, when did you learn? Like fifth grade or fourth grade or something? Like when you have a fraction. I don't know. What do they call it? Improper fraction or something? 11 times 11 plus 1. So, because this is 11 and 1 over 11. So 122. Yeah, just like when you have 3 and 4 fifths. And then 3 times 5, 15 plus 4. So that's 19 over 5. No, because this, no. Well, I mean, yes. 121 over 11 plus 1 is 122. Yeah, you can do that. I just did, what is this called? What's the official term? 3 and 1/3. Improper? See, when 3 times 3, 3 times 3, 9 plus 1, 10, so 10 over 3. Okay, anyways, that's not calculus, so I'm just going to erase it. That's just talking about numbers. So that's all I did, but not a big deal. What happened there? What was this? 122? Okay. You guys ready for this one? This is the cube root of 123. So the model, what's my model? Y equals the cube root of x. What is the closest perfect cube root to 123? Do we know? 125. Good job, miss. You must be really good with numbers. What's the cube root of 125? Oh. How'd you know that it was a perfect cube root? What is it? Take a guess. No. Some number times some number times some number gives you 125. 5. Well, I didn't hear you, miss. I didn't hear you. You got to be courageous. I didn't hear you. All right, here we go. Be courageous. Did I say that? Okay, I'll stop. My point, 125, comma, 5. Because my model is y equals the cube root of x. And the cube root of 125 is 5. Are we still okay? All right, so I have a point. Now I need a slope. So I'm going to take a derivative. Y prime equals, remember that the cube root of x is equal to 1/3, is equal to x to the 1/3. So what's my derivative? 1/3 x to the, yeah. Now you're done with calculus. You're just doing algebra. Just algebra. All right, I need a slope. At what value? At 125. 1 over 3 cube root of 125 times 125, because it says squared. I'll wait. Don't worry. I'll slow down. This is 1 over the cube root of 125. You guys already told me that was 5. And I got 2 of them here. So what am I going to write? 3 times... No, not 5. What's 5 times 5? 25. Oh, man. No? You guys don't know what I'm doing? Okay. What's the cube root of 125? 5. But I don't have 125. I have 125 squared. So 125 times 125. So this, remember, every time you have a group of 3, 5 times 5 times 5, you take that out, 5. And this is another 5 times 5 times 5, you take that out, 5. So 25. I guess if you had a calculator, which I guess, what do you mean? Yes. Cube root of 3, 125 times cube root of 3, 125. I guess let's show the work there first. So let me show this. Cube root of 125 close it squared means cube root of 125 times cube root of 125. You could have put the square after the 5 there, but I put it on the outside. Doesn't matter. This is 5. This is 5. right? Are we good? Okay. What's 3 times 25? Oh, we have 3/4, 75. Yeah. All right. Here's my tangent line. Someone's gonna look at this and be like, is this calculus or is this? Okay, I'll stop. Tangent line. It doesn't matter. It's all math. Math life. Y minus 5 equals 1/75. Why isn't this thing going down? There we go. 1/75 parentheses x minus 125. This is the line. This is my tangent line. This is what I'm going to use to approximate the cube root of 123. So what am I going to insert for x? Not the cube root, just the number. So just 123. So here it is. L of 123 is equal to 1/75 parentheses 123 minus 125 times or plus 5. And I should be putting approximate. I keep doing that. That's a bad habit. I keep putting equal sign instead of approximate. All right, here we go. You can put an equal sign now because that's what this is. All right, so let me take my calculator or my Desmos, and let me see what Desmos tells me. Desmos tells me, and I already forgot, 1/75 times -2, right? Plus 5. That's what it tells me. Let's see. What was the number? 123? Here it is. The cube root of that is that. Look how close that is. Minus that. Look how close that is. 0.0001. Isn't that pretty close? Oh, are you not entertained? Okay. All right, we're good. We're good. Already, let me write that down. The cube root of 123 is approximately, I already forgot it, guys, 4.9733333. 4.97333. Core, not core. All right. You know what? Montalongo asked me the same question about what was that line called. And you know what I told her? I don't know. And then Kilgore was there, and then Kilgore goes, Montalongo, did you just hear him? Your calculus teacher does not know what that line is called. And I'm like, really, Kilgore? There's a fancy name for it. I already forgot it. I looked it up. All right. Before I continue, I think this is either from an old AP exam or a course and exam description. It says percent error. Do you guys remember how you guys figured out percent error when you guys were in science? Okay. Do you guys like to go shopping? Yeah. Okay. Do you guys know how to figure out the percentage off when you go shopping? Yeah. It's the same way. So time out. Let's talk shopping because you guys all like shopping. So let's say something's at regular price, and let's give it a regular price of like $73. I don't know. I just chose 73. Let's say the sale price is $59. This is a side note. Let's see. I want to know, what do I want to know? I want to know percentage off. Question mark. How do you know, or do you just not care? You just know it's on sale and you just buy it? No, guys, figure out if you're getting a good deal. Like, I want to know. Okay, so how do you figure out percentage off? Percentage off equals absolute value 73 minus 59. I guess you could also do 59 minus 73. Whatever that is, and you divide it by 73, and you just multiply it by 100, and that will tell you the percentage off. So I don't know what this is. 59, 69, $14 divided by 73. What's that? Not everyone at the same time. You guys have a calculator? 14/73. 19%. So 14. So yeah. So are you gonna buy the item if you're only getting 19% off? You're only getting 19% off. Is it a good deal? 19%? I kind of want 30%. See, so you're happy with 19% off? I want a bigger break, but okay. This is exactly how you do this one, guys. We'll do this one together. This one you do need a calculator. So here's an example of one that you'll need a calculator. So here you go. You guys ready? So look, remember what I told you about the model? Hook up fam with a calculator real quick. Oh, you have one? Okay. If the linearization of y equals the cube root of x at x equals 64 is used, see, so they're already telling you, this is my model. So let's go ahead and find, what do I need for a tangent line? A point and a, so let's find the point, plug in 64. So the cube root of 64 is 4. 4 times 4 is 16. 16 times 4 is 64. And the calculator, you either do cube root of 64 or 64 to the 1/3. It's the same thing. Now I need my slope. Y prime equals, let's see, we just did this one. It's this one right here. So it's this guy right here. See? So y prime equals 1 over 3 cube root of x squared. We're still okay? Y prime of 64. Okay, hold on. All right. Here we go. Y prime of 64 equals, y'all ready? I already forgot. Oh, yeah, I did. Y over 3 cube root of 64 squared, which just means 64 times 64. Are you guys okay when I write it like that? No? Well, I can if you want me to put the square. And then 64 squared, right? Yeah, I can put it there. Okay. All right, that's fine, that's fine. 1 over cube root, or 3 times the cube root of 64 times the cube root of 64, so you guys can see it. So 1 over 3 times the cube root of 64 you said was 4, and then the cube root of 64 again is 4. 4 times 4 is 16, and 16 times 3 is 48. But I make mistakes all the time, so let me know. 16, 32, 42, 48. Yeah, we're good. So there it is. So here it is. Y minus, where's my point? 4. Yeah, let me write it. Yeah, here's my point. I just didn't write it technically. 64 comma 4. Y minus 4 equals 1 over 48, parenthesis, x minus 64, close. Are we still okay? All right. Distribute. And here we go. I'm going to use, what value am I going to put in there to solve for this one? Cube root of 66. So L of 66 equals 1 over 48, parenthesis, 66 minus 64 plus 4. Let's see what that number is. I did it again. I put an equal sign. Approximate, and then put the equal sign there. All right, here we go. One over 48. Parenthesis. Was it 66 minus 64? I guess you don't have to. You can just take the difference of that, but I'll just put it in there. And it was plus 4, right? So there it is. Now I'm going to find the percentage error. So here we go. I'm going to put a fraction. In the top, I'm going to go cube root of 66. So because I have Desmos, I'm just going to go to 1/3. I know that Desmos has the cube root somewhere, but I'm just going to write it to the exponent 1/3 like that. Minus, and I'm just going to do copy paste. Copy, paste. I don't know if you have the copy paste feature on your Desmos for testing purposes. I'll find out before we take the test. All divided by the actual value. And then what do I do with that? I multiply that by what? For the fraction, to get it as a percentage, sorry? 100. There it is. Take the absolute value. So 0.01%. Is 0.01% in there? Okay. Yes.
On the worksheet, you multiply the 3 cube root of 64 times cube root of 64. But what, so when it has a square inside the square root, the
Radican.
um,
It just that square doesn't mean it doesn't matter. You can put it on the inside or the outside. It just means time like there's two of them. If you put three, there's three of them.
so it's not 2 of the 64.
It is. It is 2 to the 64th.
But so it includes the whole radical and the index.
Yeah. Let me write it for you.
So you squared 64.
I did. This is the 64 being squared. This.
Oh, because in the previous example, you had just squared the inside. That's it.
Oh, it's the same thing. That means this. They're both the same. And I did, but you guys didn't like it. You guys told me no. But see, I still have a cube root here. 4 times 4 times 4 is that one. And this one here, let me change the colors. I did do this, and you guys told me no. And I'm like, okay.
Oh,
I'll just adapt to whatever you guys tell me.
No. Sir, I didn't say anything. But yeah.
No, I didn't. We're not throwing anyone under the bus here, you know. I'm here for you guys. We're good. This means the same as this. They have equal weights.
No, I get it.
No, you're good. You're good. All right, guys. There it is. And then the last one, or I guess we got a few more, but how will it look on our AP exam? Like this. I don't remember from what year, but I know for a fact this one was no calculator. And check it out. They give you everything. What's the percentage of students that got this correct? 57%. Do you guys want to give this one a shot and see if you guys can get it right? Okay, give it a shot, guys. You guys want me to start it? Okay. Let f be the function given by, and I have a function. What is the approximation of f of 1.5 found by using the line tangent to the graph of f at x equals pi over 2? All right. We're just going to use, what do I need for a tangent line? Point and slope. Here's my function. 2 cosine x plus 1. Here's my point. F of pi over 2 equals 2 cosine of pi over 2. No calculator, guys. Plus 1. So you got to at least know that at pi over 2, your cosine 0. So this, you just get 1. 2 times 0 plus 1. So if you don't know that, then I guess we're cooked. And, did I use it the right way? So pi over 2, comma 1. There's my pi over 2, comma 1. And now I need a slope. So here's my slope. F prime of x equals negative 2 sine x. So f prime of pi over 2, pi over 2 equals negative 2 sine of pi over 2. Well, sine of pi over 2 is 1, so I'm going to get negative 2. So I got my slope and I got my point. Tangent line. Tangent line is y minus 1 equals negative 2x minus pi over 2. This is the tangent line that I'm going to use to approximate f of 1.5. So here it is. Y of 1.5 is approximately negative 2, parenthesis 1.5 minus pi over 2, close it, plus 1. You do not have a calculator. Remember that. So, because you don't have a calculator, is this 1.5 helping you, or should I turn that into a fraction? What do you guys think? Fraction. What is 1.5 in fraction? 3 over 2. When you plug in 3 over 2 or transform it into 3 over 2, look what happens. 3 over 2 minus pi over 2. OMG, they have the same common denominator of 2. Negative 2. 3 minus pi over 2 plus 1. And catch up. When I distribute that negative 2, what happens to the 2's? Cancel, but don't forget that negative. Distribute the negative. So change the polarities of everything you have in parentheses. So pi minus 3. And then plus 1. That plus is this plus. Pi minus, what's negative 3 plus 1? Is there a pi minus 2? There it is. How do we feel, guys? Can we do this? Yeah, heck yeah, we can. All right. The rest are just like deltas. Do you want to do some of these for us, Ms. Kyle, or no?
Sure.
Which one do you want to do? This one?
6.
You do example 6?
Yeah.
Okay, but guide us through it. Here, come on.
So.
Oh, you're going to. Okay. Well, what do you feel most comfortable? There you go. Sorry, I'm all inked.
It's okay.
Let me go this way.
Okay, guys.
So read it first.
Let f be a differentiable function such that f of negative 5 is negative 2 and f prime of negative 5 equals 9. What is the approximation for f of negative 4.85 found by using the line tangent to the graph of f at x equals negative 5? Okay, so first you're gonna see that your point is right here.
I need new pictures.
So your point is negative 5 and 2. And then f prime is equal to, of negative 5 is equal to 9. So you already have your slope and you have a point. So you can already do your tangent line equation. So you have y minus 2. Oh, wait. Can I erase this?
And why did you find a point and why did you get that slope? And what are you doing?
Oh, okay. So you have a point and a slope because you want to make a tangent line equation to find this approximation.
Well, what?
Right?
So I'm using my tangent line to approximate?
No, you're.
No.
I don't know.
Slow down.
Okay, I think
So,
because once you find that, you can graph it and see how close it is to that curve, on the curve.
Yeah, but look, they don't even give me a curve.
Oh.
So I think what you're telling me is because negative 4.85 is pretty close to negative 5, I can use my tangent line to approximate the y value of the curve.
Yes.
And because the point of tangency, the 4.85, the negative 4.85 is pretty close to negative 5,
Mm-hmm.
as long as I'm really close, I can use it to approximate.
Yes.
Okay?
That's what I'm trying to say.
That's what she was trying to say, guys.
Okay. I just don't know how to explain it like you. Okay. So you do y minus 2 is equal to your slope times x plus 5. And then from there, you can plug in this value, that one right there. And then you're going to have f of negative 4.85 is equal to 9 times negative 4.85 plus 5 plus 2.
You should probably put approximate, but that's fine.
Okay.
I think we're fine.
Oh.
I'm sorry.
Yes.
Is it a plus because it's negative 2?
When she moved it to the other side, it's plus 2. No,
yeah.
you're right.
It'll be plus 2 because it's inverse.
I wouldn't call it inverse. Call it opposite sign.
Oh, opposite sign. I'll write it.
Yeah.
Yeah, she did it right. You move the.
No, wait. The y value is -2.
Oh, okay.
Oh, did I do something wrong?
You're fine. Just put right over here. You see how you wrote negative 5 comma 2? So the y value should have been negative 2.
Oh, I see. No, you're good. I called it the mistake.
Plus, and then we can just
Okay.
Minus.
You're good. Thank you.
And whatever that is, that's your answer.
Yes.
Good job, miss.
Yes.
Good job. No, you did good. Okay. Do you want to take your calculator out or just use Desmos? Okay. Desmos. I already forgot what it was. 9 times 0.15 plus, or was it plus or minus? Minus 2? Negative 0.65. Cool or not cool, guys? Now, because you don't know the curve, at the moment, you don't know if it's an under approximate or an over approximate, because we don't know the curve. But in about 2 weeks, you will. Actually, if we're fast enough, maybe by the end of next week. I don't know if we'll be fast enough. What's up? No. Well, if we take one of our lab days and if we take both of our lab days and do lessons, but you guys probably don't want to do that, right? Oh, yeah. We have a test on Tuesday. We can't. Yeah. Can you take it on Monday? Monday after school? Monday after school, miss. That way we won't miss, because if you come back Wednesday, we can't, All right. We'll talk right now. Example 7. Let f be differentiable function such that, here's my point, and here's my derivative. What is the approximation of f of negative 2.05 found by using the tangent line to the graph of f at x equals negative 2? So we're going to use our tangent line to make the approximation of our curve at that value. So I need a point, which I already have, negative 2, comma 3. And now I need a slope, f prime of negative 2 equals 5 times negative 2 plus 5. So negative 10 plus 5, so I got negative 5. Here's my tangent. Y, let's see, minus, what's my slope? Oh, actually, also my y value. Y minus 3 equals negative 5, parenthesis, x plus 2. I think we're okay. Move this 3 to the right-hand side, and let's plug in. So f of negative 2.05 is approximately negative 5, parenthesis, and I'm plugging in a negative 2.05 plus 2 plus 3. Let's see if we can do it without a calculator. Negative 5, parenthesis, negative 2.05 plus 2, that's going to be a negative 0.05 plus 3. And then negative times a negative is a positive 1, 2. Is that a 0.25? Plus 3. So f of negative 2.05 is approximately 3.25. 1, 2, 1, 2. Yep, everything looks good to me. Okay, we got one left. You want to do this, fam? Let f be the function given by f of x equals 5x to the 1/4. What is the approximation for f of 1.1 found by using the line tangent to the graph of f at x equals 1? Okay, we'll talk about everything else after that. Let's just do that first. So I have a curve. I need a point, and I'm going to find it at x equals 1, well, just like it said there. So f of 1 equals 5 times 1 to the 1/4, so that's just 5. So 1 comma 5. Now I need my derivative. F prime of x equals 5 times 1/4 is 5/4, and I'll slow down. I saw this, I saw. X to the negative 3/4. And maybe they're being nice to me. I used to like to do algebra here, but if I'm going to plug in x equals 1, 1 to any power, well, okay, I got to be careful because technically 1 to any power besides 0 is always going to be 1. Well, there's something called indeterminate form. Anything to is, well, I guess 1 to 0 is not indeterminate, so you're fine. Any number, 1 to any number is going to be 1 all the time. So this f prime of 1 is just 5/4. Because it doesn't matter. 1 to any power. At 1, any number here, I'll just stop. 1 to any power. 1 to any power is always 1. 1 to any power x is always going to be 1. Right? Yeah. Always. All right. Y, here's my tangent. Y minus 5 equals 5/4 x minus 1. What am I plugging in for x there? 1.1. See, that's we want to approximate 1.1. F of 1.1 is approximately 5/4 of 1.1 minus 1 plus 5. Let's see, 1.25 times 0.1. 1.25. 1.25. Well, I'll just write 5/4. 5/4 times 1.1 minus 1 plus 5. 5.125. Okay. How do you know if something is an over approximate or an under approximate? Because that's the next question. Is this approximation an over approximation or an under approximation? Justify why that is. We're not there yet, but how would we know? If what? If what is under the curve? Tell me something about the tangent line. So here's, okay, let's draw. You see this curve? Here's my tangent line. Is my approximate over or under? Under, because the tangent line is below the curve. Besides the point of tangency. But every other point is below the curve. Do you see that? All right, look at this line. Is that tangent line over or under? So my approximation is going to be a over approximation. It doesn't, but notice both lines are increasing. It does not matter about the slope of their tangent. What matters is what is this? Tell me something about that. What word am I looking for? The concavity. The concavity. What matters is the concavity of the curve. Look, if I have a curve like this, concave down, concave up, it depends. It depends where I'm at. If I'm over here, my tangent's going to be an over approximate. But if I'm in this side, My tangent is going to be an under approximate. Do you see what we're doing? We don't know enough yet. We haven't talked about concavity. We haven't talked, well, we know it from pre-cal, but we haven't talked enough about it. That's where we're going next. All right, guys, we just have, is this a good video? You think, okay. If you enjoyed it, give it a thumbs up. What?